Hello. My name is Mariana. I'm the online coordinator of the faculty. I organized this panel. I hope you enjoyed the talk with your master track coordinators or the future track coordinators. Because we are still waiting for two panel speakers, I would like to leave the floor to you to ask questions to the track coordinators. Maybe I will introduce them. Kevin Cohen from Space, Alexander van Zoulen, I hope I say the names correctly, from Aerodynamics and Wind Energy, from FPP, Fabrizio Oliviero, and then we have Alessandro Bombelli from CNO. Kun couldn't be here, so Alessandro is taking his place. And Calvin Rands from ASM.
All we did was the introductions. All we did is the introductions of the track coordinators. So while you're putting that on, the only one remaining is Julie Thuin from the European and Wind Energy Masters. That's the proper name, right? Okay. Yes, Evan. Now the floor is yours, Carlos.
Good afternoon, everyone. Sorry for keeping you waiting, but it couldn't be any other way. I'm Carlos Ferreira, I'm your Master's Program Director, and today I have the great pleasure of posing these nice people questions that they already know the questions, they have prepared the answers. So we're going to do that for about half an hour, and they're going to explain to you through this process of I posing the questions and they give the answers, what each track is about, and what you can study on each track, and what you can experience on each individual track, each one of the six. But I guess that you also will have a lot of questions that regards, for example, well, what if I get allocated to my second choice of my track, because all the tracks, not all the tracks can accommodate all the interests of all the students. Can I make this, can I make that? You might have a lot of very specific questions that you might believe that are only valid for you, but actually will be valid for many of you. So what we're going to do is that we're going to spend some time doing this process of I pose questions and the track coordinators answer the questions, and then we are going to send you the questions to you, and you can answer the questions that you find useful, okay? Then, so I think the first track question, and starting here, we'll go here on the line and we'll go back and forth, would be, what's fun about the space track?
What is fun about the space track? We're on the mic, hot mic. Right. So what isn't fun about the space track? Space is big. Space is big. You would say space is very big. It's not just about rockets. We have people that focus on propulsion and rockets. But effectively, we cover three elements. We cover the spacecraft itself, so launchers, but also once you get up there, what you release, a spacecraft, a physical element in the puzzle. Then the second question is, how do you take that spacecraft from A to B? So trajectories, calculating paths. And then the final one is, what are you going to do when you get there? Well, science or some other mission focused on planets. And by the way, Earth is also a planet, so we also turn the camera back and look at Earth.
Now, we can continue to aerodynamics and wind energy.
Of course, also aerodynamics and wind energy is fun to do, but I will say, let's say aerodynamics and wind energy are, let's say, sort of two separate profiles within the track. Aerodynamics is really the discipline which focuses on everything that has to do with aerodynamics, both from low speeds to high speeds, and therefore connects to a lot of different applications. So it can be applied for instance, space re-entry. There it can have connection with, it can connect to aircraft design, but it can also connect to, for instance, wind turbines. And in the wind turbine, of the wind energy profile, there, of course, the focus is more on wind energy as a whole, where it's not just about the aerodynamic design of a turbine, but also everything that goes around it. The atmosphere, how to build a wind farm, and these are the two components in our track.
Yeah, and by the way, good afternoon from my side. So flight performance and propulsion. I think that despite of all the other cases, the names doesn't give an immediate feeling of the track, what it's about. Basically, we look at the very complex system, like in the case of the flight performance is the aircraft, in the case of the power and propulsion profile is the engine, as a very complex system that is composed by several aspects. So we try to really look at those different aspects. So we give, let's say, an advanced feeling of several disciplines, such as aerodynamics, flight performance, flight mechanics, propulsion, when concerning the aircraft part, and thermodynamics, internal flow, heat transfer when concerning to the power and propulsion profile track. And then we try to integrate in a correct and perhaps optimal design framework. So it is very much about designing and integrating several disciplines altogether. And especially then we split these different study cases. In the flight performance one, you really take the airframe as a study case, central study case, whereas in the propulsion and power, it is really related on the generation of power and engine integrated to the aircraft as well.
Now, for the AWAM one, so that's the European Wind Energy Master. What is fun about that is that you can actually study in 2 countries. So you're studying both at DTU and at TU Delft, really focused on wind energy. So if you're thinking after 3 years of bachelor's, I've seen enough of aircraft and spacecraft, then you can look at wind turbines instead and help with the sustainability of our energy. So there's 2 tracks within rotor design. So there's actually 4 programs in AWM, but I will focus on the rotor design one. So there's 2 profiles in there. One is more on the aerodynamic side of things. So a little bit what Alexander already told you. So more looking at flow, the wind turbine as a whole, but you get to also study that at DTU, where they're very big in wind energy. Or you can choose for composites and structures, so you know more about like the blades that are made of composites. How do you design these? How do you can you manufacture that? So there's 2 different aspects that you can look at.
All right, thanks. Hello, I'm here on behalf of CNO. They say it stands for Cool and Original, which is sort of self-explanatory. No, it stands for Control and Operations. We have 2 profiles, control and simulation and sustainable air transport. In both cases, we did a lot with the control, although with different nuances. It's, for example, how you control an aircraft, how do you make sure it stays within the flight envelope, how do you make sure it flies safely. Same for a spacecraft, actually. How do you make sure the attitude is correct, etc. The other profile, sustainable air transport, I think it's a bit misleading because it misses a keyword, which is operations. It's more about operations. How, for example, as an airline, which destinations do you choose? Why is that? And there's a lot of optimization. So you have a certain performance indicator you want to maximize or minimize. And it's how about developing algorithms that give you the most suitable answer given your needs. In a nutshell, this is what we do at CNO.
Okay, and last, ASM, Aerospace Structures and Materials. In a very succinct way, ASM takes all of the ideas and analysis generated in all the other places and actually makes it into something, right? I need to make the engine, I need to make the wind turbine. And there's a whole series of challenges there because as you've learned through your bachelor, all of the analysis and design has made some simplifying assumptions, and then you run into the fact that those simplifications might have been a little bit critical, and there's some critical details that you need to figure out in terms of strength and durability and all these other things. So, yeah.
Well, from this passionate defense of structured materials, you can think that our track coordinators are a bit biased and they try to defend their own line, but they work very well together. And we have a very joint education. Most of your program, you only have a small part that are mandatory courses that are part of your specific track and specific profile. And the vast majority of your studies is elective, both elective courses, elective on your internship or joint interdisciplinary project or entrepreneurship project, and elective on your thesis. So you don't have to do the thesis with a teacher that sits at the department that is responsible for the specific track. You can do your thesis with any lecture of this faculty, or even outside, as long as it's connected to a lecture of this faculty. So actually, taking on the joke at your expense, Calvin, but we are very good friends, so let me pass this one. I think my second question is actually, if you could highlight a bit on your tracks, on how do they connect to other tracks? So, for example, Julie mentioned that the rotor design track actually runs in two lines, the aerodynamics and the structures. Yes, connects there. FPP and aerodynamics and structures connect. Structures and space connect a lot. Control puts a finger in very much, and operations and maintenance puts a finger in. So maybe if you be so kind, Calvin, if you give a bit of your perspective of how you think on your track that students would choose, how it connects to the other tracks, and how students benefit from the point of interdisciplinarity.
Okay, just some concrete examples. ASM is heavily involved in the flying V, which is normally associated with other tracks, but there's a lot of real structures and materials challenges in there to make the structural weight savings that comes out of a conceptual analysis a reality. So we do a lot of work on that. In the other departments, I know in space, we have a space structures profile. We work very closely with the space department on that, on various projects. And we're actually expanding the staff members we have with a focus on space in our particular track. Of course, wind energy, and Julie being here from AVM, she's also an associate professor now in ASM. So she also does research on wind turbines there. And also from the control and operations side, one of the big themes in ASM is safety. And the operations side, there's a lot of safety related stuff there, and we do interact a lot in there. FPP aerodynamics, aeroelasticity, if you ever want to kind of get weird things, like there's a speed called the divergence speed, that's the velocity you fly at where your wings break off. And all kinds of weird structural aerodynamic interactions where you need to be multidisciplinary in both areas. So,
I think I'll be a bit shorter. The closest match, I think, is with the FPP, because, for example, if your aircraft design changes, or especially with new technologies like electrification, hydrogen, if they change, it also changes maybe the range of destinations you can reach, or maybe the fare you have to charge your customers. So I would say the closest match is between control and operations and FPP, because aircraft design is very much intertwined with the operations that the aircraft can perform. With the other departments, at least as far as I'm concerned, I don't see any strong link, but maybe maybe my answer was wrong.
Well, maybe your
other colleagues can
will tell
elaborate.
you the strong link in a sec.
Thanks. I'll immediately start with that. As I said before, so it's both aerodynamics, so you would follow the part of the same courses as the aerodynamics track or the wind energy track. And same for ASM, you would get some ASM courses. That's how I construct my program. I just pick on these guys. But on top of that, obviously design is a huge thing. And if you adopt the design philosophies of FPP, so you can learn more about design, obviously from that track. in operations, there also you can make several choices. So for instance, if you have damages in your wind turbine in operation, you can make several choices. So what is your maintenance schedule? How do you operate? Do you operate it at lower speeds and so forth? So we can learn a lot from CNO in that aspect. Space, unfortunately, not so much right now. Maybe we can discuss. Exactly. So that was as far as I wanted to go with this.
Yeah, so the flight performance and propulsion FPP has been named already quite sometimes already. I will just add that we have a quite a strong correlation with also aerodynamics, and especially now there is quite a strong research activity going on integrating propeller into the airframe and exploiting some aeropropulsive interaction, for instance, and it's something that we already cover in some courses and also with some experimental activities. With space and especially there is quite a strong correlation in the propulsion and power profile track, because you have to generate power to launch vehicles into space, quite a large amount if I'm not mistaken. We also cover part of the turbo machinery that is needed also for space vehicles, for instance. Also, it's worth to be mentioned that the multidisciplinary goes also a little bit beyond the faculty, because already Alessandro mentioned hybridization, electrification, use of hydrogen, so that also we are looking to some courses that are actually taught in other faculties, such as fuel cell technology or electric machines, for instance. And it's up to you to decide whether or not to cover also these parts.
Okay, I think that for the aerodynamics and wind energy, if you look at the overlaps and let's say commonalities within the tracks, of course, there's a very clear common interest between wind energy and the European Wind Energy Master, which has already been indicated. And a lot of students are always asking, should I go to FPP or should I go to aerodynamics? If you're looking, for instance, into aerodynamic design. And there it's always a little bit in aerodynamics, we start a bit, let's say, fundamental, looking at the flow from the physics and thinking about both computational and experimental ways to study these flows. So develop experiments, but maybe also new measurement techniques or new computational techniques. And there is a possibility to, for instance, through, let's say, elective courses, focus a bit on aerodynamic design. From the FPP, you could, from your program, focus with electives, maybe a bit more on, let's say, the development of experimental techniques. So there is a possibility within both tracks to kind of tailor it to your own need. And we have, of course, also quite a strong relation with space, especially when it comes to hypersonic flows and the research that's done there, which is very relevant for space rockets, re-entry, but also new propulsion devices like scramjets.
Okay, so Carlos, how are we doing on space time? I cover space, but we've also got a time limitation.
Time is relative in space.
Okay.
Einstein said that, so.
Okay, so we have a bit of space to talk about that. Okay. So I think you've already seen, I don't necessarily need to add, why is it important to understand these links? Well, one reason is that some of the tracks have a maximum capacity for the number of students that they can admit, simply because we have to be able to guarantee the quality of the education. And so we've had to create these maximum limits. And for space, as well as for some other tracks in the past, there have been these questions and concerns about, well, what if I don't get my number one choice? If I have as first choice space, for example, what if I don't get in for some reason because the maximum capacity was limited? That's why these links are very important. And it turns out that you can actually focus on space in a number of the other track directions. So whether it's from structures focusing on gantries to the structure of spacecraft themselves, control and operations where you have to control the spacecraft. You can't just throw it out there and let it spin. You won't get anything done. All the way through to aerodynamics and propulsion. So there are a whole lot of links. And so examine those carefully when you're making your choice, your ranking of your most preferred track and your second and your third, because all is not lost if you don't get your first choice. So I think that's an important comment to make.
Thank you so much for that. Oh, you
Yeah,
can keep it there,
I'll hold
this
it.
one. I think there was a question about what we are looking for in students, but I dislike that question terribly because I never look for anything on students. I think I would like to ask a different question. This because all these track coordinators, they are track coordinators because they have the responsibility, among other things, to have a vision about what education each track should be and to transfer that vision, work on that vision with you. And they are chosen carefully because they are very dedicated people and they have a long track record of advising and mentoring students. So my last question is ask each one of you to remember a very nice experience that you had with the student, either supervising a master thesis or advising in a difficult moment, and that you can share so that also students can imagine what they can expect in terms of support and experience when they work with you. Since you are here, thank you so much.
So it seems that I'm holding the mic.
You are holding the mic.
Indeed.
It was all planned to put you on the spot.
Yes, quite. Yeah, that seems to be a pattern.
But take
here,
your time to think
Yeah.
about and recollect your
Right, I
student.
just need a few minutes. A moment, a particularly poignant moment.
Something that touched you.
So one of the things that, one of the lectures that I give in the core course in astrodynamics as part of space, we talk about the motion of things, Newton's laws applied to the motion of things in space in our case. And one of the weeks is dedicated to the motion of the moon, not so much because we're only interested in the motion of the moon, but how do we get there? And what are the ramifications of its movement? And one of the things that I like to do after the first half of the lecture is actually pull up an image, which is a compilation of photos that were made of the moon as it moves throughout the year. And it's set to music. And these are actual photos, so not a simulation. And you can watch. I've spent 45 minutes talking about gravity and a variety of forces that act. And then everybody sits back and we dim the lights and you actually watch the moon dance. And it really draws you and it captivates you because everybody thinks, oh, I see the same side of the moon all the time, right? Turns out that's not true. And the moon doesn't just move around the Earth. It actually has quite a complicated motion, which is beguiling. Yeah, you can watch it every evening when there are no clouds. But it's also incredibly dangerous because if you send a spacecraft near the moon, you think it's all round and smooth. Turns out there are pockets of gravity that destroy most spacecraft. So it's very, very captivating, dangerous, and tranquil, as the astronaut said at the same time. And so to have that excitement, I think if you forget all of the other things and you learn how to think straight and remain excited throughout your course of studies, regardless of the track, then we've done our job and you've done yours.
Please.
It's going to be very difficult to top that, but I think that typically you always feel, let's say, proud and also very, let's say, good for the student when we have the final thesis defense, especially if the family is there, and you can, let's say, again send a new let's say, master of science into society, and you know that they have their baggage and their capabilities to also build a better society.
Seems like that someone stole my answer. No, I mean, I'm used to actually explicitly ask to the student that I supervise at the end of the master, how do you feel? How was it? They look me quite exhausted, say, okay, they have been 2 busy years. Well, actually, put in brackets, 2.5 busy years. But it's worth it. In the sense that most of the times they tell me, at the beginning, I thought I was not able to do this job. At the end, I did it, and I was satisfied. And that's it.
So I have a slightly different perspective to share as well. So I get the students from AOM typically in the second semester. So they start February in Delft, while they have already spent the first half year in DTU in Denmark. So when they come here, you're not getting them fresh. They already formed a group. They were a special group within DTU. Then they come here and they're a special group within TU Delft. That really creates connections for life. So what I like is that when I talk to the students after a few years, after the AOM program, they're still in contact with all the students that they were studying with, and proud to be an AOM alumni.
All right, I guess most of you are here to talk about the start of the process, of the master process, but I want to talk about the master thesis, as some colleagues already did. And I supervised a student last year, I believe, who came to me with a special topic I didn't know anything about, which is aerial firefighting. And I was a bit skeptical because we like to supervise students on topics we know a bit, but he wanted to develop an optimization model, which I know at least. And then I realized, I think some of you might be second year, some of you might be third year, so you're about to approach a DSC. Actually got inspired by a DSC assignment from Calvin, aerial firefighting. So it's nice, it's a different type of collaboration, but it's bridging the bachelor and the master. And in the end, Calvin was also part of the graduation committee, which again was very nice. And what I liked about the topic was we talk a lot about, it's all about money, mostly about money in aviation, but it's also about the societal impact. And maybe making aerial firefighting a bit better, a bit more efficient can maybe help saving lives in the future. So I feel like it was a very nice graduation topic. And it came from the student and it came originally from Calvin. So again, it was a nice collaboration.
And very interestingly enough, that student now works at the NLR, and he's coming back, and we're running new DSC projects next quarter as a follow-up of his master's work. I'll be very quick. The one thing you've heard about classes and thesis and all of that, but doing a master's is also fun. And I think that's part of the thing that I like. One of my best memories on the first week, we do an escape room in ASM. We lock you in the study collection, and you have to use all the knowledge you learned as a bachelor student in order to escape. We do an ASM sports day where the students create football teams, and you get to, kick the arses of all the professors who form teams that don't perform very well. But it's a fun time, and there's a lot of that in your masters as well. So,
thank you. So we have a few minutes for questions, or maybe we'll take a few minutes more because we start a bit later. As you know, the most important thing today is the match between Germany and the Netherlands tonight. I don't know who you're going to support. Have fun. There is this box. Do not kick the box. It is not a football. But are there questions that you like to pose us?
That's a tough throw.
Oh my God. Okay, this will be the moment when I hurt the student. So you throw it back. Yes.
I have a question regarding the projects and just regular courses. How is the combination of those in all of your masters? Are there more projects or are there more courses, or is it likely the same?
So the complexity of that question is that there's variations in the master's program in the sense that there's a core, and I think for most of the tracks, the core is really course-based. It tends to be, you have your 5 core courses that you have to take, and then in the profile it gets a little bit specialized. There is a lot more applied and project-based courses, but from my knowledge, most of those are in the elective space. I'm just kind of looking to make sure to nod. There might be some overlap in the profile, but there is space for project-related stuff across the faculty. Like you can actually build an aircraft in the flight hall. That is one that is open and go through the operations and certifying it. That's a completely project-based course without any lectures. So there is space for all of them, but the required or mandatory elements of a track and profile are mainly, with a little sprinkling of maybe lab work and stuff, it's mainly lecture-based, course-based.
You will tend to find that in the masters, you will not be in classes of 300 people and such. The classes will be smaller. There'll be much more assignment-based grading than actually exams. And it's usually easier. It's easier to do the master's than to do the bachelor because, first of all, you are much more mature. You are much more experienced. You know how to play the game, for the lack of a better word. You know how to get your courses done. And you are also much more emotionally connected to what you are learning. So you are able to see what you are learning, what it values to me. It's much closer to what you're going to do afterwards. So students tend to find that the process of doing the masters, learning, achieving their courses, doing all the project work tends to go much smoother than what they remember from the bachelor. If you did the bachelor, the master's is a piece of cake usually. Well, a relatively hard cake, but a piece of cake. Other questions, please.
Down here.
My question is there a set amount of students for the elective courses? And if so, does the placement for the masters have anything to do with it?
Elective courses are a responsibility of the lecturers. So each lecturer will set up what each lecturer believes is the capacity the course can handle. And that will vary. For example, a course that relies on a lab or equipment can only handle so much. A course that relies on a lot of contact hours between the lecturer and the student, then the lecturer says, I can only do so much. At the beginning of your academic year, between September and October, you will prepare your choices of courses and profile. Usually, the vast majority of you will get them automatically approved. Maybe a few of you, because of one or two more unusual choices, you'll be invited to sit with one of these nice people or one of the additional profile coordinators to discuss what is your idea, how things come through. And then one of the important things is to contact the lecturers of your courses and make sure that you will register immediately on Osiris as soon as possible and to contact the lecturer that is available. I think maybe you can talk more about how often it happens that courses are not accepted.
Okay. Yeah, I also have something to
For that, check Brightspace. Or no, sorry, not Brightspace, Study Guide. Study Guide. Most of the courses that have any sort of limitation, it's outlined in there, as well as the procedure, because different lecturers have different registration processes. So always go to the study guide and look for the information there.
But maybe you can talk a bit to your experience of what happened this year, if you found many students finding this problem or not.
Yeah, so on the face of it, there is not a connection between the limit for a track and what happens after that. Okay, so if you're in the track, then you choose a profile and go in the direction of that profile after. With us, it's the first quarter. I think that's maybe similar across the board. You will find, in order to manage the flows that in some cases within space, some profile courses first accommodate all the students that have chosen for that profile, and then may be able to help students that are not in that profile in some cases. But it's not connected again to the limit of the track. Again, what Calvin said, check the study guide carefully. Okay, so it's not our intention to block people in any way, but in order to manage the constraints. So that's our way of communicating with you. So check for each course the study guide carefully, and then you'll have more information.
And maybe if I can add on top of it, also with respect to the experience that I had this year, we as a track coordinator have an important responsibility that is basically to guide you in the selection of the courses and to approve the study plan. But it doesn't automatically means that you will have a spot on the course that you select. So I would like to stress that the moment we, as a track coordinator, approve a study plan, then go check on the study guide and in case talk directly to the lecturer to be sure that you can enroll the course.
In fact, if we're talking about those details, I might make the request to, before you submit your study plan, actually think about the study plan, which means you've taken a look at the courses and you're convinced you can actually do the courses you're putting in your study plan. Just a small request.
Then I'll add one more detail.
Great.
All this information that we are giving you now, we will be again available at the start of the academic year. So 30th of August, we'll be here. I'll make some nice welcoming, and they will all also be available, spending even more time with you, answering all these logistic questions. And I will invite you not to worry about logistics when you're choosing your master's program in your track. Choose what you want to learn, what you want to have fun with, and the logistics will find a solution afterwards. Other questions? Oh, please. No.
Maybe to follow up a bit, especially for electives, they're mostly, at least for our track, in Q3 and Q4. It might be the case that in Q1 you have an idea, but then you can change your list of electives. And I was actually surprised to see how many students do that. So it's actually quite common because maybe you study your core course and you realize one elective you chose is not really a good fit and another one is a better fit. Of course, we are also, as Fabrizio said, it goes via us, but usually, unless it's something very weird, we accept most of the electives. If you see you're German and you select as probably it's more a PDP, a German A1 or A2 course, maybe we're a bit reluctant. Or if you are Dutch and you select a Dutch course, maybe we're a bit reluctant, but oftentimes we are okay with your choice. And if you're not okay, we can always discuss.
But if you're Dutch and you choose the Delft method, maybe it's a creative choice, so we are open for discussion. Other questions? Yes. Easy.
So, just a general question. How much do you interact during the aerospace masters with the aerospace industry? For instance, companies like ESA, NLR, Boeing. Are there a lot of projects that work together? And is it general for all tracks, or does it rely on which track you choose?
I'll be very quick. You forgot KLM. That's a big one.
I would generally say you interact potentially a lot, of course, during your internship, that's without saying, but maybe more so in a thesis or a thesis project. Much of the research we do is interacting directly with industry. For courses, generally speaking, it's majority being taught by people here. However, there is often in a lot of course cases guest lectures from industry, and that's on a course-by-course basis. It's also on a topic basis, right? If it's a very fundamental theoretical science, you don't need someone from industry coming and giving that lecture. You have enough nerds here to give that lecture. But if it's something a little bit more applied, yes, we often bring in guest speakers and that. And then you also have, outside of your coursework, the very active student societies in all of the tracks often organizing guest lectures to come. And I encourage all of you, no matter what track you take, engage with your student society. The departments support initiative from students to invite guest lecturers or guest talks outside of a course. You don't have to worry about an exam or any of these things, and you're just interested. There is a lot of opportunity for that.
Maybe.
Yeah, and I think that that is also the nice thing to stress about the master is it is up to you as well. So if you would like more interaction with industry, you can arrange that through a master thesis in industry, obviously your internship, but it is a bit up to you.
Just to add to the point of connections. So we are not only a school of education. We are one of the top research centers for aerospace and wind energy and affiliated topics. So it means that, yes, we run a master's program with 1,300 or 500 students, no, for lost track now. But we also, at the same time, run, I don't know, many hundreds of PhD students. 340 now? So that will correspond, I don't know, to how many millions of euros a year of funding from industry, from Europe and such. So, and that means for each, well, in average, maybe that if we have 300 PhD students, maybe about 150 different projects with industry, research partners, and many of these projects become master thesis topics that you participate with. So that's where you get a lot of your first contact outside of the faculty, the internship that you can connect to your master thesis that is actually allowed. So there's all these possibilities that you can consider. There was another arm here. I don't know if it was the same question or no. No, to my
Thank you.
mistake. Maybe another question? How are we,
Yeah.
Mariana?
There's
2
one back
minutes?
here, just behind you.
2 more questions, then we're done. Last question, so it seems. You have the last question. Congratulations.
Shit. I was wondering, could you present to us like the most interesting piece of research that's being conducted right now in each of your faculties?
Mine. Whatever it is, it's mine. So you want us to declare that our research is the most interesting
Well,
research we're doing, or
inside your track, what would you?
I will not choose anything I'm doing or it's close to me. I love that. I love people thinking that an airplane doesn't have to be a tube with some straight wings coming out of it. I love when people dare to say that what industry is doing is good enough until now, but things keep on changing, design drivers keep on changing, and it's time to think fresh and to think new. So when I see things like those and many other projects, that really excites me. Even I don't touch anything like that. I don't do anything on that project, but it's a nice example of something I like to see.
So I guess that to have a complete answer for that, I maybe invite you to visit the different desk later. But I guess that as a general answer, being a sort of expert that is working from quite time here, I really like the fact that we are trying to answer to some really practical societal challenges. So it's not just for the sake of scientific research that we are doing research. It's really to answer specific societal needs that are now becoming really pressing. Just sustainability, just to name one, but I mean, and then you can see a lot of declination of what does it mean sustainability for space, for structure, etc., for instance. But yeah, it's really oriented in giving an answer to some societal demands.
And our time is up. Thank you so much for coming here. I hope it was valuable. There's plenty of food and nice people to further engage with you outside. Thank you very much. See you outside.